Solve the following rational equation and show your answer as a solution set. The first thing that we want to do with any rational equation is to determine what values are restricted. What would cause the denominator to be 0? Any of these denominators for that matter. So if you look at these, we have an x, a 5, and a 2x. Well, I can definitely say x cannot be 0 because 1 over x. Okay, if x is 0, then we're dividing by 0. That also carries over to the 2x. If you said 2x equals 0, we've seen previously that would mean x is 0. So that is the value that it cannot be. All right, next thing we want to do. This is always first step. Second thing we want to do is find the least common denominator. Okay, least common denominator. And for this particular question, let's see, the least common denominator multiple of 5 and 2 would be 10. So our least common denominator is 10x. All right, step 3, we're going to multiply every part of this equation. Every part of this equation by 10x. So that would mean, go ahead and write it like this. Distributing that, I would get 10x over x equals, that would be 1 times 10x over 5. Just go ahead and write it like this. Plus 3 times 10x over 2x. Now, things will reduce. I'm going to combine a few things. So on the left side, and this is the fourth step, is solve this. That will be 10 equals 2x plus, let's see, the x's will cancel there. So that should be 15. Now we'll solve this. We'll subtract 15 from both sides. So we have negative 5 equals 2x dividing by 2. X equals negative 5 over 2. Now, because that value is not one of the restricted values, this is good. This is good. Now, you can always still check. And let's see. I'm actually going to go ahead and check this real quick. 1 over x, okay. It's 3 over 2 times negative 5 over 2. Just make sure I have all those in there. And yes, okay, both sides are the same. So x equals negative 2/5 is our solution. So we want to write that as a solution set, the set of negative 5 over 2. All right, next question. What values would cause the denominator to be 0? Which values are restricted? Well, because we have an x minus 3, that's the only real denominator we have, both of those, we can see that x cannot equal 3. So we should always check against that before we finish. All right, next, our least common denominator. Domain variable restrictions, our least common denominator, is x minus 3. I'm going to go ahead and put that as a quantity. So now we're going to multiply by that on every term. Okay. Multiply that through and then cancel some things. So this is going to be x times x minus 3 over x minus 3, and that really should be in parentheses as well. This would be 3 times x minus 3 over x minus 3 plus 9 times x minus 3. A few things reduce. This forms a 1. This forms a 1 as well, so this will be x equals 3 plus 9 times x minus 3. Distributing the 9, I see I have 9x minus 27. All right, and then combining like terms, be negative 24, so 9x minus 24 equals x. We can add, let's subtract 9x. I was going to move the 24. So this would be minus 8x equals minus 24. And then dividing by minus 8, I see that x equals positive 3. Ooh, don't be so hasty to box that in. All right, x equals 3, but we just said x could not equal 3. So our solution is this. It is the empty set. Or, writing this in words, you would say no solution. All right, for our next example, we need to, again, find what values are restricted. And we have two different denominators this time, x minus 1 and x plus 2. So x cannot equal 1 or minus 2. X minus 1 would be 0 at 1, and x plus 2 would be 0 at negative 2. And our least common denominator, because we have those two varying pieces, we'll have x minus 1 and x plus 2. Multiplying that through everything here. Oh, not parentheses there. X minus 1, x plus 2. X minus 1, x plus 2. So multiplying that through, I have 3x minus 1, x plus 2 over x minus 1. I have 1 times x minus 1, x plus 2 over x plus 2. And then I'm going to bring that down here. Plus 9 times x minus 1, x plus 2, divided by x plus 2, x minus 1. All that is one line. Now, several things reduce. Here, the x minus 1 reduces. Here, the x plus 2 reduces. And here, all of that reduces. So my resulting equation is 3 times x plus 2 equals 1 times x minus 1. I'm actually going to drop that. We'll keep it there, actually. Plus 9. Okay, distributing, we have 3x plus 6 equals x minus 1 plus 9. Combining like terms, we have x minus 8. 3x plus 6. All right, now we can subtract x to get 2x plus 6 equals minus 8. We can subtract 6 to be minus 14, so I'm going to bring that over here. 2x equals minus 14, and then last, dividing by 2, we see that x equals negative 7. Now, I'm going to check that against my values of 1 and negative 2. Everything's good, so my solution is negative 7. Our next example, same process. What could the denominator not be? And again, it looks like we have x is not equal to 0. Our least common denominator, let's see, 6, 4, and 3. Let's see, 12 is a multiple of all those. So 12x, multiplying that through. Multiplying that through, we get 1 times 12, so that's 12x over 3, minus 12 times 7 is 84, 84x over 4x. Let's see, 1 times 12 is 12x over 4, minus, that'd be 12x over 6x. Now we reduce those to get 4x minus 21x equals 3x minus 2. So this on the left side is negative 17x equals 3x minus 2. We can subtract 3x to the left side to be negative 20x equals minus 2. And then last, dividing by negative 20. That reduces to be x equals 1/10. Now, we only said that x could not be equal to 0, so that means our solution is the set of the number 1/10. All right, we have one last example for this segment. Again, what can our denominator not be? Well, it appears that since we have x plus 4, the opposite of 4 is negative 4, so x is not equal to negative 4. Now let's multiply everything through by, least common denominator is x plus 4. So I'll multiply every term by that. So this first one is 3x plus 4 over x plus 4 minus 7 times x plus 4. There's no denominator, so we'll leave it alone. And this will be minus 4 times x plus 4 over x plus 4. Some things reduce. This here, this here. So 3 minus 7 times x plus 4 equals minus 4. I'm going to subtract 3 from both sides so that I have negative, I better distribute. Minus 28 equals minus 4. Combine like terms, negative 7x minus 25. Adding 25 would be negative 7x equals 21, and then dividing by negative 7, x equals negative 3. Since that is not restricted, there's our solution set.